Hello, this is Mike at GameFromScratch, and today we're going to take a look at the PlayCanvas HTML5 game engine. In fact, we're going to take a second look at it. Now, if you've been following this channel for a while, you may have noticed right after I started it, actually, I took a look at PlayCanvas the first time as part of the Closer Look series. And since then, it hasn't really changed a whole lot. It's just been refined across the board, so the developer experience is a lot better. But the basic underlying concepts have remained the same. The structure, the pricing, the way it works, those kind of things are all pretty much the same, but the coding experience, the editing, the tools, those kind of things have all been incrementally improved. So I thought I would jump in with a bit of a tutorial to show you how PlayCanvas works today. And what we're going to do is go ahead and create a bowling game, a very simple bowling game. And in fact, I really like this example. It's one of those things that I worked with and I thought, this is a great hello world type thing. So it's something I may use over and over again for showcasing 3D engines. So anyways, we are going to be creating a simple bowling game with the PlayCanvas game engine. Now, before we get too much further, let's do a quick recap of what PlayCanvas is. It is a browser-based 3D WebGL-powered game engine. You can develop entirely in the browser. It is very performant. It works quite well. The tools are quite nice. So if browser-based turns you off, give it a few more minutes. It probably is a lot better than you were expecting. And in terms of the 3D space for HTML5, it is definitely one of the front runners. Basically, it and Babylon.js are the two native ones that come to mind immediately. And then there are a bunch of game engines that export out to HTML5, but you're never really dealing natively with code. So if something goes wrong, you're at the tool maker's mercy. So I like developing natively in the language I'm ultimately compiling to, and that's where PlayCanvas really shines. It is subscription-based. You can get it for free, but your projects are completely public. So if you want to start creating private projects, then you have to start paying. And we're looking at $15 a month in that particular case. Or you get into organizations where you need team management features, and you want to get rid of the PlayCanvas branding, you can go that route. Now, you can also host your own stuff on your own servers. And behind the scenes, the PlayCanvas engine itself, the underlying technology of the engine, is entirely open source. It's the tooling that is not open source. All right, so without further ado, that is a bit of a recap of what PlayCanvas is. Now, let's take a quick look at the game we're going to create. And that is this guy right here. Very simple. It is bowling. Do A to go left, D to go right, W to shoot, and it hits. B, you can reset your ball, and you can do it again, like so. Or R to reset completely. So not the most advanced thing you've ever seen in your life, but it is a full-functioning 3D game with collision detection, physics, you name it. So like I said, I really like this as a model going forward, so I may actually use this for future 3D game type reviews or tutorials. At the same time, if you are a patron backer, I did create a bowling kit. It's published on the patron site, and it's also on the patron Dropbox link. So you can get all the assets I used to create this. They're all available there. Nothing super advanced. It's basically just a textured lane, pins, the texture maps, and a title screen. But those are all available to patron backers. And once again, thank you for your support. All right, so let's jump into this guy. Now, first things first, the PlayCanvas original Closer Look link is available. I will put this down below. So if you want a bit more in-depth of what the engine is about, this will get you started. Now, obviously, some of it is outdated because this was done back in almost 2 years ago to the date. I will link that down below. And next up, we're going to head on over to PlayCanvas.com. Now, you obviously need to create a PlayCanvas account to continue. As I said earlier, a completely free account will work fine. That's what I'm using today. And I'm going to go, let me start this over again. PlayCanvas.com, once you've logged in, when you go to the website, it will bring you to here. And now what we want to do is go ahead and create a new project, like so. Blank project, and we're going to call this Bowling Master, and then I'll call it YouTube because I've already done that once. It's the world's greatest bowling game. It has to be public because we are not using a premium account. You can turn VR on and legacy script support on, neither of which we need in this particular case. And we are set. So now we've gone ahead, we've created our project. Now we're going to go quickly into the settings for our project. So come over here. Now I've been told that this one step we're about to do here, this enable 3D physics, isn't required. Basically, when you add a rigid body and make something physics oriented, this will automatically be toggled, but I'm going to set it anyway. So this is where you do the top level configuration of your site. So for example, we can do our game artwork here, and I will do that. So this is coming from the, all right, where'd you go, Dropbox? Oh, there you are. Patreon, game kits, bowling title screen. So this is the title screen for your application. Obviously over here you can see you set the resolutions you want to run at, how to do the remapping between different resolutions. Your descriptions over here, you can change the way that the resolution works. And you can do team-based stuff, but basically I'm working alone. So we're good there, and we'll save that up. So now that we've set up and configured our project, we're just going to go ahead, clear, and click the editor button here. And this will open up the editor for our game. Very straightforward. You can see over here is your 3D view. Here is your assets. This is where the various pieces you go together to create your game go. Over here is your hierarchy, or it's also known as a scene view in most environments. And let me just mute that so we don't get notifications anymore. All right, come on. Quiet hours. All right, there we go. So over here is your scene graph, which is basically all of the entities that populate your world. Now, this is a traditional entity component system in that an entity is an object in 3D space, and it is composed of components. So, for example, the camera entity is a entity plus a camera component with its various different properties. We'll get into this in much more detail in a moment. And you notice over here on the right-hand side, the settings come up dynamically to whatever we're picking. So now we want to go ahead and start populating our game. And we don't need a lot of this stuff. We do need the camera, we do need the light, we do not need the box. So you can click that and hit delete, or you can right click and hit delete. It's just like working in an offline application. It's very good feedback, it's quick, it's performant, so you don't really notice that you're working in the browser most of the time. So we're gonna bring in our various different assets. And I'm gonna do this all at once so we don't have to keep coming back here. I'm gonna go ahead and just come in here, go to upload, and it'll figure out what we need. So we've got a bowling pin, texture, so we'll bring in that. We need upload our bowling lane texture, and then I've exported both of those out from Blender as FBX files. So we go back here to bowling, and we want FBX, the lane, and the pin, like so. And we're gonna need one other file for much later on, so remember I did this. We're going to go ahead and grab hit.wave. And this is the sound that basically, when the bowling pins hit, it will play that. So you'll see it automatically created various different files for us. So the FBX was brought in, bowlingpin.fbx. And what this did is it created a JSON file, bowlingpin.json. So here you can see there is our bowling pin. Now one of the things you'll notice is no texture. So we're going to go ahead and fix that now. So come on down here to mesh instances. You'll see material1, material1. So let's click that, see that, so it's this guy right here. So we'll highlight it. All right, stop that. Okay, I can't do it this way. Let's escape that. So material one, see if I get this right. So downside of my naming convention. So this, I think, is bowling pin. And what we're going to do is set the diffuse channel of it to our bowling pin texture, and the other material is our lane, and we're going to go down to its diffuse channel, and we are going to set it to our lane texture. And now I'm going to remember that I forgot to bring in one other asset, which I will go ahead and do now, and that was excuse me, a normal map for a bowling lane. Now, normal map just allows you to add a little bit more detail to geometry without actually having the detail there. So we've gone ahead and we'll go back to bowling lane texture. Bowling, or did I not? I didn't rename it. All right. Bowling lane. And let's give it a normal map as well. So you can see the preview of it up here. We go into normal map, we'll pick it, select our normal map like so. And then you can pick the amount that it affects right here. This is the general bumpiness, the amount that the normal map applies. All right, so that is our textures now defined. We'll go back to our JSON objects, so our bowling lane and our bowling pin. So let's do bowling pin first. So bowling pin.json, bowling pin.json, there you are. Bowling pin JSON, go back, our material, actually our material is defined. Okay, why are you not showing up there? All right, so our bowling pin should be good. Now our lane right here. Once again, we come in here, pick our material, bowling lane, like so. Should be defined. Now there is one catch with the lane. The lane was actually defined as it's a single-sided plane. So what I need to actually do is come down into it. I think it is here. Others, and what we want to do is front faces. All right, so our bowling lane is now defined. Now that's just because it was a single polygon object. So normally you're not going to have that, but I just basically changed the way that the drawing order works because it was, you know, a non-depth related polygon object. So now we're going to go ahead and instance our lane, bowling lane. Just bring it up, drop it into our scene. All right, something is going seriously wrong. Let's do a quick reload. Grab our lane, drag it into the scene. Oh, duh. All right, bring our lane into the scene like so. And you'll see there is an instance of our object. It's a little bigger than we want it to be. So we can either rescale it down over here using the entity portion of our component, or I could come on over here and do the scale this way. So let's scale it down universally just so it fits our screen, like so. All right, so we now have that in. What we want to do, so we got bowling lane, we're happy. And we're going to set the bowling lane up completely before we continue on. So the first thing we're going to need is some physics on this guy. And that consists of two components. First off, we need to add a collision mesh, and this is going to determine how physics simulations work on this guy. You'll see here under, once we added that component, there's a couple of different options. There's a sphere, capsule, cylinder, mesh, which is massively overkill for what we need here. And what we'll do is stick with box. Now what we need to do is get this box shape right here. By the way, I'm scrolling in and out using the wheel, and you can pan using the middle mouse button, and you can orbit using the right mouse button for your. So there's your typical navigation. Plus you can also change your camera settings to set cameras right up here. So what I want to do, oops. Go back to our bowling lane. So I want to size this guy up so that it's roughly, you know, the size of our lane. We can use the, oops, Josie, come on. So we will go ahead and set half extent. So Z, we need to be about, so you can see the color coordinate here, Z-axis, Y-axis, X-axis. So you can see is a Y up game engine. Let's make Z, say 3 times. Oh yeah, that was X. All right, let's make X back to, let's see, 0.3 or 0.2. No, where do we start with X? 0.5. All right, so let's make that about 0.7. Nope. A little bit of trial and error going on here, but you can see the shape being defined over here. We just basically want to cover it. So we're good there. Now let's do Z, actually properly do Z this time. So 3, not enough, 4. Getting there, 4.2. Yeah, we're good. All right, and then Y, we need this to be minuscule. We'll make it 0.5. Looks like we could use a little bit more here. All right, so there our physical shape basically encompasses our bowling lane, which is where we want to be, and we're good to go. Now we need to actually go ahead and add physics to this object, and that is done using a rigid body controller. Now a rigid body component is basically, this says I take part in the physics engine, and there are 3 different ways that that can happen. This is pretty standard. If you've worked in other game engines, it's pretty much always the same thing. There's static, dynamic, and kinematic. Now, static means I exist in the world, but I'm part of the simulation, but I'm not affected by the simulation. It's a bit of a lighter weight object. Basically, you're saying, here's a stationary object in the physics world, which is exactly what we want our lane to be. Now, it has some settings here, less than others, but it's got friction and restitution. Now, friction basically is how two surfaces interact when rubbed against each other. So the more friction, the slower things will be. Less friction is more like ice. Restitution instead can be thought of as bounciness. This is how hard or bouncy the surface is compared to another surface. So a very high restitution, think I get the directions right. Very high restitution is very bouncy. Very low restitution is very not bouncy. So if something hits it, it's just going to clunk and come to a dead stop. That might be completely reversed. I screw that up all the time, but I think I got it right first pass. But as it stands for this particular simulation, ironically enough, the settings that we get by default almost perfectly match what we want it to be. So we'll stick with that. You can play around with the physics to your heart's content. Just make sure that it's static and make sure that your shape is done and set to be basically the same shapes as your underlying polygonal mesh. So now that we've gone ahead and created our bowling lane, let's go ahead and create a bowling pin. So we just come up here. Now we can do it a couple ways. So we can either do it the way we did before, is just drag bowlingpin.json into the scene, like so. And as you can see, we're way too big, so we're going to just scale that down. We could have also gone new entity, mesh, and then picked the options from over here. Same basic end result. So now we need to do a little bit of setup here. I don't think we're scaled down quite enough yet, but we're getting there. So we're going to size our pin. We're going to move it up. So it basically rests on the scene, and we probably want it to actually rotate around the y-axis by 90 degrees. All right, so now our pin faces the right direction. Let's move that guy back like so. So there is our bowling pin. And we obviously we're going to do 5-pin bowling because 10 pin is for heathens. And we're going to have to set up the first pin, and then we're going to duplicate the heck out of it. So we're going to go ahead and set all the rest of the parameters up for this guy before we duplicate it. So our model is set up, our texturing is all good, everything is set that way. But what we want to do is go ahead and add a component. Once again, same guys. So collision, instead of a box, in this case, we are going to go ahead and make this a cylinder. And we're going to make this cylinder much smaller. 0.3, nope, 0.4, 0.5, that looks good. Yeah, that's about right. So there is the collision bounding shape for this particular guy. I'll go ahead and add a component to it. We add our rigid body. Now in this case, unlike the last time, this guy is going to move around as part of the simulation. So what we want to do is go ahead and create this guy as dynamic. This means it is fully calculated and controlled by the underlying physics engine. And again, the defaults are pretty good. They actually kind of work well for bowling, so we're not going to really change them. But you see here, we got a couple more settings. Mass is obviously the weight versus volume in space. Damping is how fast it falls off, slows down when a collision occurs. I believe I might be screwing that one up again. Linear factor and angular factor, I have no idea offhand actually. Scaling factor for linear movements along each axis. Yeah, I actually don't know what these two settings are going to control in this particular case. And then we've got the friction and restitution once again. So we got everything set as we want it. Now we just need to go ahead and create a couple more pins. Now the thing is, I want to be able to identify the pins commonly later on. So what we're also going to do is go ahead, and this is for code later down the road, we're going to set a tag here for this object. And we're going to create it and tag it as a pin. This means later on we can say, okay, give me all the pins, and anything with that particular tag is going to be returned in that result. And now that we've got our pin, let's go ahead and duplicate it. You'll see here, you could copy it and you could duplicate it. Duplicate will give you all of the different components as well. So that's what we want. So duplicated it, moved it back a bit more that way. And then again, we'll take that guy and we'll duplicate. Like so, I think that's about right. And then we'll take that guy and we'll duplicate. So, and we will take that guy and we will duplicate like so. So we have a bowling pin set up. I think that needs to move just a little bit more, but for the most part, there is a bowling alley populated with pins. Good work. All right, so now all we really need to do is go ahead and create a bowling ball. In this case, I'm not going to bring it in as a mesh. I'm just going to make it as a procedural entity. So this is the other way we could have gone about creating things. So we're going to come here to the root of our hierarchy, create a new entity, sphere. And you'll notice there are various other entities we can have here. So here's your different procedural meshes here, and then your lighting, particle systems. But what we are concerned on at this particular point is this model. So we're going to scroll it down a bit. That's a little too big for our liking. So let's select scale. That's about right. And we will rename the bowling ball. Okay, we're good to go. Let's bring this guy back. So, up. All right, and we probably want to go ahead. Oops, I think I just off-centered that guy. Now we probably want to go ahead and add a material for this guy. I'm not going to use a texture map in this case, but I'm going to show you some of the options you can do for materials. Come on down here to Assets, go Plus, and Material. Let's create a new material for us. We will call this Bowling Ball Material. And what I want to do is just make it kind of a shiny white. So we can go with pretty much the default here. You got the two rendering models, old-fashioned Pong shading and modern physical or PBR shading. Go with whichever one makes the most sense for you. But what we want to do, we're going to keep it white. So diffuse channel is basically your color channel. This is where you normally have your texture map for the primary colors. We can also change the color of our object here. So if we wanted a red glowing ball or whatever, we can set it here. But we're going to stick with white. But what we're caring about in this particular case is actually specular. And this is how light interacts with our surface. And what we want to do is make this guy shiny, which is under the glossiness setting right here. And we'll just change the glossiness like so. So you can see the light reflecting off it. There we go. So we now have a shinier ball. I'll go back to our bowling ball in the scene. So bowling ball, material, click, and we will just give it the bowling ball material. So now we have our shiny bowling ball and we are good to go. Now obviously we have a couple other things to do. We need to set this guy up with its collision object. It is obviously a sphere. 0.3 is about right. Yeah, so that's around the size and shape of our underlying object. Looks good. Now next up we need to go add another component. This is a rigid body, and once again it is dynamic. Now you may be wondering what kinematic is. Now kinematic is a lot like dynamic, except for the idea behind it is that your code or your script is going to be providing the motion for it. So it participates in the physics simulation, but the way it's controlled is different. But in this case, we're actually going to control all of our movement using physics. So we're going to keep this guy as a dynamic body. And I think we are set there. Now what we need to do is go ahead and create some code. Now I'm going to jump ahead a little bit for something that I'm going to need when we're dealing with code. And that is another component, and it's a sound object. Now remember earlier I added that wave file? Well, now we're going to go ahead and use it. You'll notice when you add a sound component to an entity, a whole lot of options here. So you can have positional audio, so that its location in the world affects how it's rendered, how distance falls off as you get further away, the pitch of it, etc. But what we really care about here is slot number 1. So you can add multiple slots or multiple sounds to the sound component. We only really need one in this case. It is a sound that we are going to call hit, and it is going to use the asset hit.wave that we uploaded earlier. So you can sit here and preview it like so. All right. So now that our sound is there, what we need to do now is create a script. Now I'm going to go down here and create it this way. New script. Bowling ball controller. This all scripted in JavaScript. That created our script for us. You can see it is missing. Did I do something wrong? Let me do a reload, see if it grabs it. Yep, there it is. Okay, so there is our script. We'll go back to our bowling ball. We add a component, type script, add script. You can do it down here. Hey, why are you not giving me the option to scripts? This is the one thing I had trouble with last time too. Something about, let me delete the script component, add component, script. All right, I'm not sure why I have to do that by hand, but there you go. We have our script is now attached. We'll go back. I didn't mean to do that. Go back, click here, bring the edit button, and this brings us into our script editor. Now the cool thing you'll notice here is you get full IntelliSense, pops up, tells you what you need to do or what you want to do. You see errors on, oh, I screwed up. Okay, I have two scripts here and it's not giving me the right one. So let me go back here, delete that script, add script. All right, let's just delete this guy. Something's wrong with the way that I did that whole order of operations. So go ahead, we'll go ahead with bowling ball component. All right, so select our bowling ball, script is hooked up. We shall edit that script. It brings us into our script editor. All right, so here we go. So as you saw, you got syntax highlighting, you've got tabbed browsing, so you can have multiple code editing files on the go. You've got this code completion going on. Your debugging happens in the browser using the built-in debugger there, so you can set breakpoints, etc. Since this is JavaScript, they don't really need debugging directly here for setting breakpoints, etc. because it's done in your browser. Pretty much every browser worth its salt now has a built-in debugger, so you're good to go there. And now what I'm going to do is actually cut and paste in the code, so you don't have to watch me type this code. It's not exceedingly complex code by any definition of the word, but it is a lot of typing, and you don't want to sit here and have me watch me type the entire thing. So go ahead and save that, and we'll revisit the code in a second. Don't worry. So I'm going to do a quick reload here, just make sure that that hooked up. So go back over here to the bowling ball, down here to our script, parse it. Okay, we got an error. Why do we have an error? Again, this is the glitchiest port I've found in the project. I don't know why adding scripts is, it's probably a user error thing, but I ran into this pretty much every single time and I haven't figured out the solution easily. Because this will go away, and this is kind of stupid. So if I come on back here and I reload my project, and I select my bowling ball, my script should be fine. Maybe I have to do a play. Ooh, my bowling ball is huge. I'm gonna have to fix that later on. All right, see if I can. All right, bowling ball. Scripts. As you can see, there's no saving involved. You can jump in and out of projects really easily, especially when something goes wrong, as I'm currently experiencing. So, bowling ball. This is stupid. Shouldn't have to do anything here. All right, give me 1 second. All right, not sure that I've done anything. I basically just deleted the script, came down here to add script, and then I can select my script and we are in and good to go. So I go over here, click edit. Brings us back to our editor. So this is one of the areas where I've had a little bit of glitchiness. I don't know, again, if it's user error, if it's something underlying in the program. I'm not really sure, but this part is not the smoothest by any means of picking up and attaching this particular script to the object. It's got to be something to do with the build order. But anyways, you'll notice here, right here, I can set the speed of my object. So if I want to make the ball a little bit faster, I can change it there. The minus is because that is that direction. I could rotate everything 90 degrees and make it a positive if it, you know, if that worked better for you. But you can see here this attribute was being set. Well, this is coming from the script. So we'll open the script back up, and you will see right here at the top, I defined an attribute for speed, used it as a number, etc. right down here. And then later on in the code, we get that particular, let me see if I can zoom that in a little bit for you, easier to read. So we set the attribute right here for speed, and then later on when we fire off our bowling ball, when we press either the the space bar or the PC key, you'll notice we can assess it using just simply this .speed. So it's very easy to bind attributes back that can be changed in the editor by a designer or etc. Very easily exposed in this manner. So let's just do a quick walk through this code. It's quite simple what I'm doing here. There's the attribute for the speed that I'm, again, exporting out to the editor. This is the initialize function. This is called when this actual script is, basically started, when it's attached to it. When the object it is attached to is created, this function will be fired off. What we're doing is wiring up two event handlers. One is for collisions. So when a collision occurs in the world, this function will fire. The other one is for the keyboard on the key down. We're basically going to fire off the function on key down. So we're just basically handling events in the world with these two. We'll see later on the two functions that we define here, the on key down and on collision start, are later on. Next up, remember I told you earlier when we set the pin tag so we could identify all the pins? Well, that's exactly what we've done here. You can see this.app.root.find by tag. So basically saying the current scene, the root of it, find all child entities with the tag pin. So now we've got an array of all of the pins in the scene. And what we're basically doing is saving an array of starting positions and starting rotations for all of those objects. The only real idea behind this is so that later on down this road, when we reset the physics, and tell the pins to go back to where they started, well, we need to know where they started. So that's really all we did. We just looped through all 5 of the pins in the game and took a copy, remember, because the way that JavaScript does things by reference by default, you'll end up just taking a reference to it, and that is completely useless because the physics simulation will constantly change these values. So do a clone so you've got your own distinct copy of the original starting positions of all of the various pins in the world. We also do the same thing for the ball. That way we can reset the ball later on. And then we got a little variable here saying that the ball is moving or not. And this is going to be used to determine, if we're starting off or not, basically. Here is that collision function I talked about earlier on. And basically this this will be fired off whenever this object collides with another object. First thing we do is check if the other object is named bowling pin. That means we hit a bowling pin, and in that case it did. We go ahead and hit the .sound.play. Remember when we added this guy to our bowling ball? This is a reference to sound, and we're saying play hit. And that's exactly what this code here does, and basically is going to play the audio when there's a collision between the ball and some pins. Finally, we have our keyboard handler. Again, we define this on keyboard up here. This is going to be called whenever a key is hit. We check for the space bar or the W key, in which case we apply an impulse, which basically said put some force behind this object. It's a one-time as opposed to a constant. Or am I screwing it up? It's a constant as opposed to a one-time. So apply force does it once, apply impulse makes it kind of a constant push in said direction, sorry. Again, this is controlled by the attribute speed. So this determines how fast the ball is being pushed down the lane. So if you want the ball to go faster, you can change it in the attribute setting earlier. We hit the R key. This is resetting all of the everything, basically resets all the locations of all the physics entities. So we go through all of the pins if we saved the positions and rotations earlier on, and we just set them back to where they started from. Now, since it's using the Rigidbody controller, we use teleport as opposed to setting the position directly. You can't set the positions directly with a physics rigid object. So you actually have to, if you want to override the underlying physics engines, positioning, etc., you need to set it yourself, which is where teleport comes in, basically saying override whatever's going on in the engine and put this here. And so we're basically saying put all of the pins back to where they started and get rid of any of the velocity that happens to be applied to them. We also do the exact same thing to the bowling ball. We have this other one here, so we can hit the B key and just reset the bowling ball's position. This allows you to keep throwing the ball while the pins are still down. And finally, we move left or right simply by applying a small impulse, so like 0.2 or negative 0.2 left or right. And this allows us to move our ball left or right. And finally, our we declare an update function that we're not actually using. But this is if you had per frame logic, you would put it here in this particular code. And that is it. I think I'm missing my reach. Maybe that's why it went wrong. So anyways, our code should now be hooked up. There might be an error. I might have to look back in a second. Only thing I want to do here is change this ball down slightly. So let's resize it down. I didn't realize it was quite as big as it was. And of course, the collision Yeah. So our ball is now set up correctly. Let's go to our camera quickly. Yeah, that works. So our default camera position, you see our we have a preview in our scene of how the camera looks. So if we go ahead and move it, it will change in the preview. So that'll work for me. Go ahead and press play. Hope everything is set up right. And done. So if I do left, you see the result there. Right, you see the result there. And spacebar. And there. Now one of the cool things, side effects, is you can continue to press left or right as the ball is going. So I'm going to hit B again. And there you go. Ooh, almost. And that is bowling in PlayCanvas in, let's see, 35 minutes. So, and that had probably 5 minutes of me screwing around trying to get the scripts to hook up right. Now, of course, I did make an error there. If I figure out what it is, I'll put that in the comment down below. But there was definitely a mistake made there with wiring the scripts up to the actual components. It shouldn't have been that complex, so I'm not sure what went wrong there. But otherwise, it's pretty smooth sailing. You can actually get quite a bit done in this engine, and you can get some pretty staggeringly good result. Now, one thing you might think is, God damn, that's ugly on our lane. And what you're probably experiencing is the texture filtering in effect here. I'm going to go show you how you can turn that out. So bowling lane, we can come down here to the other setting. Oh, wait, nope, not other. Brian, come on. Or do I actually go to the texture itself? Bowling lane texture. Yeah, here we go. Filtering, and we can turn it to point. So now when we go ahead and look at our lane, all right, that's even worse. What is wrong with you? Oh, you know what? I think it might be my fault. Yeah, it's the stupid scrolling of the browser. So there you'll see your texture, your underlying texture is a hell of a lot smoother. And on that topic, we can actually have a lot of control over the graphics here. So we go back, let's look at a couple things we didn't actually use in this particular example. So first off, we have right here, we can go into the settings. And we go over here, you see the different rendering options. So a lot of control. You've got fog setups if you want. You can override the resolution here. You can set it to use WebGL, etc. We got light mapping. We have the loading screen. This is an upgrade option, apparently. You can determine which order your scripts actually load in, which this one's already set. We have global physics levels settings here, so we can change, the way gravity works. In this particular case, it is negative 9.8 units down the y-axis, which is pretty standard. We have some control over how the editor works, grid snapping, etc. Our grid size. We can go back here, right here, then manage your scenes. So this is the current scene we're in. We can obviously have multiple scenes in our project. And that's basically, a scene could often be considered a screen or a mode or obviously a scene. But once you're done, like so, I haven't done any builds yet, so go down here to publish, and you can download a build and host it on your own server, or you can go ahead and publish it on their server. So I'll go ahead and do that. I will click publish now, and it will go off and do a build and create us a URL like so. And I will link this URL down below if for some reason you feel like bowling for the next couple of minutes. And this will create the shareable link of your project. Don't know why my internet's so slow today, but there you go. So there is our project. Ta-da! And again, as I said earlier, so this is in the build version. You're not going to see it here, but let's go on back. Let's change that edit setting. So we'll go to our bowling ball. We will change the speed up to 14. Let's go ahead and run that. So then you can see the effects of that in real time. And boom, super fast ball. And of course, we could also change the physics. So we took stock physics here. So every single thing in the scene has the same weight, which is a little ludicrous. The ball should weigh more than the pin. So you want to tweak around with the physics, etc. You easily can. So we have our bowling ball. We'll go into the physics components for it. We can set its mass to, say, 3. And then you'll see its effect on the pins is much more profound. And it's a lot slower, because it's got more mass to work with. So then we're going to go on back to our speed again, change our speed up substantially, go ahead and run that. So we're a lot heavier, and hit with a lot more force. And you can see as a result, the pins are flying off a lot harder. Hit B to reset. Actually do an R to reset every... Hey, why is my R not working? I think I made an error. I think I know what my error is too. So there you see, the added physics really has a profound effect on what's going on. Now I got a feeling, and this is very important, you need to match name for name. So everything here, I went with bowling pin, and I tagged them as capital P pin. So my R isn't naturally resetting it, so I'm gonna go back to my code, and I'll take a quick look. Yeah, so there's the problem. That wasn't actually working. So you have to match your code exactly. And so this was actually finding nothing. It wasn't storing any of the values, so the reset wasn't working. And that should be enough now. I go ahead and run it. And then all right, you're irritating me now. Pin should be right. And bowling pin is the name I used. Bowling pin, bowling ball. Bowling pin, bowling ball. Okay, I do not know why my reset is working. Anyways, it's a small coding error I've done in here. It's a cut and paste error. It's probably insignificant, but basically something is not firing off. If you're really kind of concerned about it, go to GameFromScratch.com. I'll link it down below. This is a two-part tutorial, and in the second part, the code is there verbatim, so you can copy and paste it in if you're trying to recreate this. I've created some kind of a copy and paste error, all on me. I won't bother, you know. This is one of the downsides of working with JavaScript is, you know, very case sensitive, but it is not compiled. So sometimes tracking down these stupid typos is a little bit annoying, and we're not going to get into that. So that is it for now. That is PlayCanvas, a very cool in the browser 3D WebGL powered game engine. As you saw, the workflow is pretty solid. Very few hiccups. The one that you saw, again, may have been self-inflicted. I'm not sure. But it is one of those things you can work around. Every game engine has its issues. There's nothing shocking there. But I've surprisingly ran into very, very few of them. The coding structure is very straightforward. The importing functionality works just great. You know, I had no problem slotting in the workflow, getting my assets in. The only challenge, again, was that I created a planar object, so it's a one-sided polygon, so you had to flip the draw order. And that's one of those things you're going to run into regardless. It's one of those things that between graphic applications and graphics engines, that's pretty much universal. So got nothing really to fault here. You know, web-based 3D may not be your thing, but if it is, I do highly recommend you check out PlayCanvas. It's a very cool little game engine, something that I do think is worth your time if, you know, this is something that you're interested in. So anyways, I hope you enjoyed that. If you did, of course, please do click like. And on this channel, we cover all kinds of game development related stuff. And if you're interested in that, please do, of course, click subscribe. Now, once again, the Patreon backers, all the assets you saw used here are available on in the game kit for bowling and also on the Dropbox, Patreon Dropbox. And again, thank you so much for your support. That's it for now. Thank you, everybody. I will see you all later. Goodbye for now.